So now we want to look at our second order differential equation using Simulink. But the second order, that means that expression, that model has been differentiated twice. And that is what is being represented here with this double prime that you have here, y double prime. That means the second order differential equation. If it's y single prime or whatever variable is being used. If it's single prime, that means it's first order, double prime, second order, triple prime, that will be third order, then fourth, and so on and so forth. Now you have an initial value problem like this, where you have y double prime plus y plus 5y prime plus 6y equals to 0. And the initial condition for your y prime, when it's at 0, is 1, and when for your y is 0. So for you to get your output, which is your y in this case, you need to make this y double prime the subject, then integrate this twice for you to have your output of y. So we can just do that using our 3D paint. So this is y double prime plus 5y prime plus 6y equals to 0. Then making y double prime subject, you have minus 5y prime minus 6y. Then when you integrate both sides with respect to time, y dt, double integral, open bracket, minus 5y prime minus 6y, close bracket, dt. So here you have the output of y, and also your double integral, open bracket, minus 5y prime minus 6y, close bracket, dt. So that means this expression will go into the double integral to get the output of y. So how do we do that in Simulink? We just switch over and just go get the menu here, then open a blank model. Let's wait for that to open. So the blocks that we'll be needing, we need the integral, we need our sum block, and we need our display. In this case, that will be our scope. So here we have a workspace window for Simulink. And from our library browser, we can go to our commonly used blocks, since we have used those blocks very often recently. So we can add this to our workspace. Then we'll be needing our scope, add it. Then we need the integral, we need 2 of that because it's a double integral problem. Then we need our sum block. We have that also to our model. So let's just try to arrange these blocks. Let me zoom in. So our output y will come out after the second integration. So this is y. So here we'll have y prime. Here will be y prime. Double prime. And what will be going into this first integral will be our y double prime. So now we have minus 6y and minus 5y prime. So that means our y prime is gaining minus 5 here, and y is gaining minus 6. So we need 2 gain blocks because our output, which is y, is gaining 5 and 6 here. So we need 2 gain blocks. So this is our gain block. Add it. We need 2 of that. Add it. So one will serve for y prime and the other for y, which is for 6. So let's flip this block here. Then we'll flip this block as well. So here we can hold control to branch this line. We because my y prime will go in and it's going to gain 5. So I'll change this to 5. Double click, left double click, change this to 5. And my y will gain 6. That is 6. So this is what we have done. 6. Y is gaining 6 and y prime is gaining 5. So I can pull that down. So here, this one goes here and this one goes in. But don't forget, you have to change this to negative because they are both -5 and -6. So that will be negative. We apply. We'll just pull this down a bit. So what we have here is y prime, y double prime, which is the same as equals bracket open -5 y prime -6y. So that's the signal that will be on this line. From here, y prime goes into the gain block. We have 5y prime here as the signal on this line. 5y prime, and on this line will be 6y. That's the signal that will be on this line. So you have y, that will be 6y. Then you have y prime gaining 5, that will be 5y prime. So when this one goes into this negative end, it will come out as -5y prime. And when this 6y goes into this negative end of the sum block, it will come out as -6y. So all of this going into the first integration, you have your y prime, and when it goes into the second integration, you have your 6y. So all of this will go into the double integral block. So these two go into this first integral, come out as y prime, and here come out as y. And don't forget, the question states that for y prime, the initial condition is 1, and for y is 0. So for my integrator here, I'll change this one to initial value of condition of 1. This one will remain at 0 because I'm told that for my y prime is 1, and for my y is 0. So now I can run my simulation to see what my output will be. So our outputs on the scope block. So these are outputs. You can see these outputs. This is how our y is behaving. Then let's see if we can refine this using the refine factor. Sorry, data import and export. So refine factor of 10. Let's see how we can refine the output. So we run it again and check the outputs. So we can see that we're able to refine the output of y. So that is an example of the second order differential equation using Simulink modules to solve okay, problems. So here is another example for your second order differential equation, simple, or your harmonic oscillation. You know, from your physics, when you have a body like this, you have this mass attached to a spring, and you want to know how this spring will be displaced based on the mass that has been attached. Now the distance of displacement is your x. Now the equation is this. That will be m x double prime plus kx equals 0. Now the same way, if you make your x double prime the subject, you have your minus kx to the right, which is this minus kx to the right. Then your m will come as the denominator to this side, what you have here, and you have your x double prime equals minus 1 over m kx. So you can equally model this using Simulink. Now we can just do that by open a new workspace window. So we would need the double integral as well. We need the integrator block twice. And also, what do we need? We need so our x is the output in this case. X is the output. So x would be multiplied by k at some point, and also 1 over m. So how do we do this? So let me zoom this in. We have our integrator block, and we'll zoom out a bit. So we have here. So we need our scope to display our value of x in that scope here. So let me just annotate this. So you have x here. And you have x prime here. So the x prime. Okay, so we need kx at some point here. So let me use my game block for my k value. So let me just flip this block. Flip the block. So this will be my k, which is, so whatever in the value of k is will come in here. So after then, you have 1 over m minus 1 over m. So in this case, you want to use a math function. So I'll need a math function that can do a reciprocal. So if you go to your math operations, you have your math function block. So this is our math function block. I need to change this from exponential to a reciprocal. So this is reciprocal now. So whatever coming here will come out as 1 over whatever value goes into that block. So I'll need a constant block to put in my m value. So minimize this. So I have my m. So let me just annotate this constant block for m. So I have m here. So m goes in here to come out as 1 over m here. And also I'll need a gain of minus 1 so that my m can be 1 over minus 1. Let me put in my product block. Let me check for my product. This is my product block. So I'll equally need a gain block again. So I need to flip this block. Flip this block. No, sorry, I need to flip it back. Okay. So the signal that will coming here will be my minus 1 divided by m into kx. Signal that will come in here. So this is my m, this is my 1 over m, so I'll be needing so what will come out here will be 1 over m, 1 divided by m, will be the signal here. So I want to have minus 1 gain here. So I can have here my minus 1. I need to arrange this block in a better way. To arrange the blocks. Okay, I think it's looking better now. So bring this a bit to put this block here. Okay, put this one backward. So what I'll have here is my 1 over m, and what will be here will be my m here. So on this signal line I will have minus 1. This signal line I have minus 1 over m, minus 1 over n here, and my k value, that will be my k multiplied by x will be on this signal line. I will have here kx here on this line, because at this point this is my x coming to this gain block, which is the value of k, so I'll have kx here. So kx will come to this product block on this end. My m will be here, will come out into this reciprocal as 1 over m. Then it will gain minus 1 to have minus 1 over m. Then into this product block to have minus 1 over m, multiplying kx into my integral block. So I can have this model. Now let's look at what the question states here. It says my k is 5, m is 2. K is 5, m is 2, and initial condition is for x is 1, for x prime is 0. So which means this one is 1, this is 1, and this one will be 0. This is for my x prime, this is for my x. So my k is 5, and my m is 2. So I'll just move this a bit. Minus 2, so I can run this now and get my output. So this is what my x is like. I can equally use the refine factor to refine my output. Let's drop down, change this to 10. I can try to apply it so it stays at 10 all the time. So you can see it looks better now. The curve looks better because I've refined it in my refine factor. So that's what my displacements will look like for my x